There's no like that tree to that flagpole.
Yeah.
Somewhere else.
The problem is right there, that was
Okay.
You're 6 hours.
It's that 6 hours.
Take those up. I don't want to take them. I think I might have.
That. Electrical research.
Can't be that way now. The tree and the flagpole have to be equal distance from each other.
Open discussion. If you don't understand the words or whatnot, that's a good discussion. But getting quiet now. Do we have any brave volunteers that think they know what they're talking about? Please go up. Wheeler, good work. Grab one of those magnets. Put it where you think. Now, no disagreeing or anything like that. I like the idea. Okay. Anyone else have a completely different radical idea? I won't disagree with like the exactness of it. I know it said exactly 2 feet, but anyone have a complete difference about like she's where? Okay, so none disagreement, so that's good. Raise your hand if you think she. Oh, you got one?
Yeah.
Please go. Grab a different color, if you will. Okay. Clever, clever.
We don't put it,
Okay. Wherever you think you should.
oh, stay right here.
Okay. So he's floating out in the middle of nowhere. Clever, clever. Okay. Now, anyone disagree with that? Okay, I'll disagree with that one. Even though, hey, I like the choice. I like the choice we can talk about. I'll disagree with that one. Why? Oh, okay, you're just disagreeing to disagree. Okay.
Just say find the location on the marker.
Say it again.
Find the location on the marker board.
Had to be on the marker board. I like your idea. We'll talk about it. It's clever, but it said it had to be on the marker board, so clever. We'll discuss why he's somewhat correct in a way, but not according to this description. Anyone else have a different one than Wheeler or Chris here? No brave souls. You're all gun shy. I don't want to talk. Okay, let me turn off the timer here. Otherwise, it'll go off like a horn. All right. Let's discuss. Okay. What does it mean that I had to be equidistant? Let's talk about that word. Equidistant.
equal distance.
Equal distance. So the idea is that the tree and the flag, so we got my broccoli tree and my flag, they have to be equidistant. Equidistant, if you look at the distance, let's just say the piece of paper, my objects, there is a distance between these two objects, correct? There is an actual distance. I want to be equal distance between them. So somewhere in the middle. It didn't matter where you're at, as long as that maybe this is like 1 foot, and that's 1 foot, that's equal distant, right? You're going to be in between. Okay? Now, my disagreement with the marker here. It looks like this marker is too close to the flag and too far from the tree. Agreed? They look like they're different distances. So, your intentions were correct. I'll give you that. Right? So, you have to be equal distance. So, in theory, there's an imaginary line that's going right between them. Your actual marker here has to be on that line. Because it has to be the same distance. That was terrible. Where's my eraser at? It has to be the same distance between both. So you got to be thinking about, okay, where is that dashed line at? And can I get on it? Because again, how I made it was just measuring distance and then measuring lines and figuring out where they crossed. And just marking a bunch of them until I have this dashed line. Okay, so in theory, I should be somewhere on this line. Now, the other thing that you were considering too, the second thing, I'd be exactly 2 feet from the fountain. 2 feet from the fountain is not very far. Okay, 2 feet, exactly 2 feet. So that's what, 24 inches? So I got a stick here. So 24, So 24 is what, right there? Okay. That's the marker I was looking for, that, roughly. Okay, close, I'll give you that. Now, Chris, you picked a completely different one, which I really liked. He put his out here. It's clever. Why is this one clever? Even though it didn't match, because we did say that it had to be on the marker board. Why is this point that he was holding out here clever? Let me explain. Ooh. You don't have an idea why this spot could work if I didn't have that first sentence, it had to be on the marker board?
Still 2 feet from the fountain.
Yeah. If you have your fountain here, you have to imagine there's like this imaginary bubble. There's like a bouncy ball where the fountain is the center of the bouncy ball. It's like the middle, the core of the earth. And there's a sphere going around it, a 3-dimensional sphere. If I want to be 2 feet, just make the sphere 2 feet from it. So it's got a radius distance. Radius is the distance from the middle of the sphere to the outside, the core of the earth, to the crust of the earth. Be 2 feet from it, so maybe this is 2 feet. So I could fall anywhere along that sphere, as long as I'm 2 feet away from it. Be anywhere on the surface. But if I'm 2 feet, let's say this is exactly 2 feet, right, around, I could still be equal distance from the tree and the flag here, because maybe the distances to those objects is exactly the same. That's why that's clever. There's actually an infinite number of points. But what made this crazy is that I wanted the spot on the marker board. There was one location, it had to be on the marker board. It's about the orange spot. Now, I said there's an infinite number, because if I didn't have that thing, it had to be on the actual marker board. I could be floating up here, I could be anywhere on that sphere. I could be somewhere down the road, down here somewhere, be over here, because it could be equidistant, and I could be 2 feet from the fountain. I just had to follow that path. It could be somewhere down the road there. So, the thing that you're going to figure out in geometry class, and this is why I always do this exercise first. Okay. Descriptions can be pretty straightforward. Okay. Now, do something, do a task, do this object, find this location. There could be more than one correct answer. There's more than one way to solve a math problem. There is. Now, there is ways of solving it correctly, more correctly than others. There's ones that are more detailed than others. But what you're going to find in this class is that everyone's answers could be correct. Now, the approaches could be correct. But the difference between them is a big deal. Like, especially when we're showing evidence. Like when I was pulling out a ruler there and measuring distance. So details are important. Reading every line. Like the big thing was reading like on the marker board. That's huge. That's a little detail that you might overlook. Okay, those are things to me that are important. We're going to talk about some of these words today, why this is kind of a great starter activity that discusses all these topics. Okay, we're good though? Okay, what I need from you next, take out your Chromebook. Hopefully you have your Chromebooks out.
This has been told to you, can I do that?
Yes. Okay. You need to log in, and then I'll give you the web address here in a second. As you're getting logged in your Chromebook, and it's going to seem weird, I'm going to stop the camera at this point. The reason why is I'm about to give you a code to add to your online textbook, and I don't want the whole internet to know that code. So, because I only have so many books, and I don't need some random Joe Schmo logging in and adding my book to his personal collection. Okay. All right, so once you're logged in, I'd like you to make your way to my website, mrward.org or ghvmath.com or hsmath.org. One of those web addresses, you'll get to my website, and I'll explain further. So make your way to my personal website. Stop the camera here. Okay, again, the reason why I record is so I post it online, you guys can watch what we're doing in class. Okay, today, we're gonna talk about points, lines, and planes, we're gonna do a couple definitions, we're gonna talk about some examples with this. Tomorrow will be more hands-on, I'll have a bunch of different pictures, and you guys are gonna try to figure out some stuff, and I'll ask you questions. So it'll be more interactive tomorrow. Today's kind of more lecture style, so. Goal is to get formal definitions. These were words that are fair game for the test. The definitions are directly out of the book. Sometimes I paraphrase when I don't like something, and whatever I paraphrase on the board, that's what I use on the test usually. So we'll talk, if we can get there, I want to talk about interactions today. The interactions of different objects, and that's what's going to lead us into tomorrow. Okay, and then notation. This is the big deal. I'll describe this word later. What notation is the way you answer questions. So that's, I know it's geometry, right? It's not algebra. We're not solving for x and you're finding x is 17. We're not doing that anymore. We're actually looking at objects, physical, or mathematical objects, and we're figuring out how they work and how to answer questions with it. Because maybe the question on the test is, hey, where do these two objects meet? Maybe that's a point. Maybe that's a line. Maybe it's an object. So you need to know the notation for how you answer the question. So because I'm super specific. If you give me the wrong notation, I count it wrong. That gets almost 90% of people on my test. They can't remember the notation for how you're supposed to answer questions, even though we do it every single day. So, okay, let's go through this. Let's talk about the word point first. I know it seems a little funny, but we are going to discuss the word point. We're going to go through the definition. Okay. It's a location in space labeled with a capital letter. I'll let you write that down. Again, fair game for the test. Now remember, there's certain words in that chapter 1, section 1, 1-1 in your book, what is that, like page 5 for you guys, where, I'll go through words on the board, but I won't cover all of them. There's certain words in the textbook that are still fair game. I do require that you do read your textbook. I know it's crazy. You have to read something. Every time we're in a section, you should be skimming through it during a study hall or at home. I know it seems funny, but just skimming the book and see what some of the vocab words are. See if you know them. Ask questions if you don't. There's certain words I just throw in, certain words I just expect you to know. Okay, so point is a location, space labeled with capital letters. That idea, let me grab these magnets. That when you guys were trying to find that location on the board, that was between the two found in the tree and that flagpole. It's one specific spot. It's a dot, right? That's a point. It's a location. Okay, now how you label it? You label it with a capital letter. So on paper in the book, they always draw a dot. They're going to put a little letter next to it, capital letter, I should say. It could be any letter of the alphabet, A through Z. Now, the dot itself doesn't make a difference how thick it is. If I choose to use a different size point, because these two dots are different in size, it doesn't make a difference. It's not like a geographical map where you're looking at a city and bigger cities have bigger dots. We don't care about that in geometry. It's just a location. It could be any letter. Now, how you name it. So let's say we're looking at problems and on the test, and we're looking at, okay, where do these two objects meet or intersect? That's something we'll talk about. Well, they intersect right here. Maybe the answer is like, where do they meet? So it's some letter. Say it's like point C. That's where they cross. How you answer that's called notation. How you answer the location where things meet, this is what you do. You write point, the word point in lowercase letters, and then you write the capital letter behind it, point C. This is notation. This is the part that people get wrong on my tests. They always forget the little things. And I'm super, super particular the way you answer questions. Point C. Not just C, point C, the word in front of it. That's how you answer questions. Or maybe there's different spots where they cross. Okay, questions with the word point and how to answer a question with that. The notation is huge. How you answer that question. Okay, let's go to the next word. It's gonna go with that next picture I had over here. All right. Let's talk about a line. Now, in geometry class, there's 3 types of lines. 3. We're gonna talk about the first one today. First one. The second, or I guess the second, third one, the next 2 types of lines we'll discuss, I believe will be on Wednesday this week. I think that's when we first introduce them. And then we'll talk about it Thursday as well. But a line is the distance between 2 points and continues in both directions without limit. Okay, so again, you're writing that down. It's the distance between any 2 points of the line, but then it's also extending in both directions without limit. So what does it mean to be without limit? Yeah, never stops, goes to infinity, goes forever, right? So the idea is that this is what we're looking at. Most people think of a line looks like this, right? Oh, it's connecting the 2 dots together, the 2 points. But what this thing says, it extends in both directions, so it keeps going. The only way I can represent that is with arrows. You have to have arrows on a line. So it goes through the 2 points and then keeps going. Now, again, that's a terrible line. You get the idea that it keeps going. But there has to be a minimum, of 2 points on it. There can be an infinite number, I don't care. Maybe there's another point in the inside. I don't care. There could be a ton of letters there. You need at least 2 points with the line connecting it, and then the arrows on the outsides continue on without limit. So they have to have arrows. If there's no arrows, it's a different type of line. You probably already know the names. But those are it. Now, how you answer it. So the notation stuff. Notation. So maybe one of the questions on the board was, or on the test or the homework was, name a line that goes through point D. So on the board there's a point D up there. So we have to name the line that goes through it. There's a ton of different names you can call this. So the notation is how you answer the question. So how you answer this, there's a bunch of different ways. Here's one way. You could go this. You could write the word line, then you write the 2 letters. So you're like line AB. That's fine. I don't prefer that one. That's the one the book says you can do. I just don't like it. The reason why is that to me, it's actually incorrect notation. I know some of you are like, well, Bart, I just wrote it. The book sometimes does that. It's actually incorrect. What I mean by that is if you're going to choose to write the word line, like the word line, what they're expecting you to put after it is a cursive letter. Like sometimes on the end of the arrows, they'll put these little cursive letters on the back. That's the letter you put after the word line. So line M. That's fine. That's correct. I don't know why the book feels like you can do the other 2 letters. When you use 2 letters like AB or BD or something like that, you can use any 2 letters. That notation is the one that is probably the easiest for people to understand. You write 2 letters. You can pick any 2 that you want, as long as there's multiple letters on the board. Don't use this one, the cursive letter. The cursive letter doesn't have a point next to it, it's just the name of the line. But if you choose 2 points that are actually on the line, any 2 that you want, in any order, BA, AB, DA, I don't really care. You just have to make sure you draw a mock picture above it. Line AB. I actually say that. I said it out loud as line AB, even though it's written like this. That's the notation. This is what I prefer. I know you can do it this way. That's fine. You know, using cursive letters and that. One cursive letter and then that. But I prefer this. 2 letters. So is there another name I could call this? Instead of calling it AB, what's another one I just gave you an example of? BA. Right backwards. BA. With the arrow above it. 2 arrows because it keeps going. What's another name I could give it? Say it again. Line N. Okay, got that. What's another name? DA. I like it. DA. With arrows above it. And you actually say line DA. Even though it's written like that with little arrows. Do we feel comfortable with lines? I know it's weird, you can write it 15, 16 different ways, but I prefer this one. These are just the ones I like. They make sense, they're clean. If you're gonna choose to do this, just make sure there is a cursive letter on the end and you only pick one of them. I don't like the thing that the book does where they write 2 letters. It's not actually correct notation. Book thinks it is, it's not. Okay, let's move on. Those are lines. Okay, they continue. Now I said earlier, there's 2 other types. We're gonna get those Wednesday this week. The other 2, you probably already know. Okay, the next one is a plane. Not an airplane, but a geometrical plane. Okay, now this definition, I'm just gonna warn you before I read it, has a ton of vocabulary in it. Like this one word, like if you knew this word really well, like you knew everything about the definition, what it says, like you knew everything, you'd probably know 90% of geometry just by knowing what this word says. So a plane is a limitless flat surface that contains at least 3 non-collinear points. Yeah, it's kind of a mouthful. There's a lot of vocabulary, like the definition of the word made it more complicated than it probably was before. I'm going to do my best. Now, when you see planes in your book, they're deceiving. The way they draw them, the way they explain them. I'll try my best to get this through. This will be probably our last word today. We'll probably end after this word. Hopefully we can get some of these words down. Tomorrow we'll continue and then we'll look at a bunch of examples tomorrow. Okay, what does it mean to be limitless? Goes forever. To infinity, right? Flat surface, obviously, it's got to be flat. You know, our definition of flat could be anything that's flat. Now, it contains at least. What does it mean to be at least?
Minimum.
Yeah, minimum, right? More than is particular, right? At least. So, a minimum of 3 or more points that are what they call non-collinear. Non-collinear. Not in a straight line. Non-collinear. This word is not a straight line. That's what that word means. That's one of your vocab words that's in the book for sure. Like one of those yellow words that I said you have to know. Even though it's in the middle of this definition. Most people know limitless and the word at least, but the word non-collinear really gets people. So now, what I mean by planes, my marker board's a plane. Do you agree that there's at least 3 points or more in there? The problem is, what's my problem with the thing I have drawn? It's a line. I need them not in a straight line. So I need to put some other point on the board. I'll explain that here in a minute. Okay, but I need at least 3. Now, here's my issue. The marker board's a plane because it's a flat surface, extends. So if you have really good imagination, goes from the floor, goes to the ceiling, continues. Both directions. All directions. Your piece of paper that's in front of you is a plane. It's a flat surface. Just really have that imagination that it can extend. So we have a bunch of different planes because everyone's got kind of different sized notebooks, so they have different heights. We're covering everything in the room. I have a bunch of other marker boards in this room, so we have a bunch of different flat surfaces. Why they need to be non-collinear? Why do 3 points need to be not in a straight line? Here's the best way I can explain it to you. Do you agree that my 3 points A, B, and D are on my marker board? Okay, it's a plane. It's got 3. The reason why they have to be non-collinear is because I could take a flat surface. Let's say that this is a flat surface, a plane that extends. I could put it right here, and it would go through A, B, and D. It would. I could tilt it a different way. That would be a different plane. I could tilt it differently. So now I'm going through A, B, and D again. I could go from the top. I go from any direction. I could go 360 degrees around, and every angle I could possibly make to go through A, B, and D. To make a unique plane that's one by itself, there has to be 3 dots that are not in a straight line. A, B, and C. They're not in a straight line. There's no way there's another flat surface in this room that can touch all three, A, B, and C, without being the marker board. There's not. Because think about this. If I choose another plane, here's my plane, and I go through B and C, what letter did I miss? Missed A. Well, let's go through A over here. Well, now I missed B. Oh, now I missed C. The only flat surface that can hit all three is my mark board. It's the only one. Doesn't matter how I tilt it. It's got to be flat. It can't be curved. That's why it has to be non-linear. Now, how you name it. When you name a plane, you have to write the word plane. So this is the notation. You have to write the word plane. And then you have to name at least, because it said at least, 3 dots. Give me 3 dots on the board that are not in a straight line.
A, B, C.
A, B, and C. At least 3. I could name 4, A, B, C, D. You can do it. It doesn't matter. But it has to be at least 3. That is the difference between a line and a plane. Planes, you can name as many points as you want, as long as at least 3 of them are not in a straight line. On a line, you can only name 2. Okay. Tomorrow, if you're ready to go, make sure you're getting book covers on. I know a short turnaround for book covers. Get them on there. It's all or nothing points. Bailey, for those who didn't get an online textbook, I will make sure you get one tonight. I'll give it to you tomorrow.